Hopefully you're happy with how we measure the area of a 2D shape by this point. If you're not, check out M101 for more details. Hopefully also you can see that even if a shape doesn't exactly fit the rectangular grid we can create, we can move bits around and get clues as to how much space that shape is actually taking up, just like we did with the triangles in M102. Today, however, we are looking at a brand new shape that you may or may not have heard of before. It is the parallelogram.
The parallelogram. It's a quadrilateral.
Yeah, just so we're all very much aware, that means a shape has exactly 4 sides and 4 corners.
With 2 pairs of parallel sides.
The parallel sides are the same distance apart all the way along.
This means, you guessed it, its opposite sides are the same length.
I agree.
Quiet, you. Look at this snazzy shape in all its jaunty glory. Did you know by this definition a rectangle is also a parallelogram? Only you usually see them all wonky, like this.
If we used the same method we used to find the area of a rectangle, we would end up finding the area of this grid. As you can see, there's a bit of the grid without anything filling it, and a bit of the parallelogram that isn't accounted for at all. However, because the opposite sides are the same length, if we were to break this extra bit off and drag it over here, we would see that it fits into the gap perfectly. So the grid we've made is actually ideal. So finding the area of a parallelogram isn't actually any harder than finding that of a rectangle. All we have to do is take the base length, in this case that's 6 centimeters, and multiply it by the height of the parallelogram. In this case that's 3 centimeters. And we're remembering that we were multiplying it by the height, not by the length of that slanty side. So if we do that here, we have 6 multiplied by 3, which gives us 18. So the area of this parallelogram is 18 centimeters squared. Have a go at the following. Even if you think it's easy, still do the calculations to reinforce this method in your memory. Pause the video and have a go now. Let's look at the answers. Shape A had a base length of 8 centimeters and a height of 2 centimeters. So that's 8 times 2, 16 centimeters squared. For shape B, we had a base length of 12 centimeters and a height of 7 centimeters. So that's 84 centimeters squared. Shape C included some extra information to check you knew which bits you were using. We needed to multiply the base length by the height, not the slanted side. So that's 9 centimeters times 4 centimeters, which gives us an area of 36 centimeters squared. Did you get them? If not, don't worry, just go back, have another look at the video, or go and ask a teacher for some help. If you did, there's one more 2D shape I'd like us to look at before we step up the complexity with this area work, and that is the trapezium.